Matplotlib has a sub package called or sub module called the MatPlot. That is what we use in plotting graphs. All right, so basically when you type the Matplotlib inline, it tells Matplotlib to display your graphs inline. All right, so that's what we talked about the other time. We also made mention of the figure and then the axis, and then the picture was that the figure is more of like the board, and then the axis tells you the coordinate. So provided you have a whiteboard that you want to plot a graph, so the figure represents the whiteboard, and then the axis represent the coordinate. So once you run this particular code over here, as we've done it, you see that you have a board. So this particular board, this area is called a figure, and then this is the axis. Okay, these are the coordinates. Okay, so we also realize that you can likewise change it to suit your preference or to suit your research needs. Okay, all right. Okay, so once you are done, then we started with a basic plot. Okay, so we said this one is, let's say, months of the year. Okay, and then up to June, and then this is the revenue generated by a particular company. So if we want to plot this, all that we need to do is to create the figure and then the axis. Okay, then figure and axis, and we said that this subplot method actually gives you the opportunity to create both the figure and then the axis. That's why we've created the variables fig and then the ax, which represent the axis. For the figure and the axis, that will be created by the subplot, and then we can specify the size of the figure, so the size of the space that we want to plot our graph. All right, so once we are done, we can just run ax.plot, okay, month, comma, revenue. So here it gives you a line plot between for the month against the revenue, whereby the revenue occupies the y-axis and then the month occupies the x-axis. All right, so once we plotted, so last week we saw something like this, and I know that you've gone through the code, so I'm not going to take time to go through most of them. All right. Okay, so here we try to create a data collection tool like that. Okay, so this particular code helps you to collect data, and it passes on the data to a list, which you can use to, you can visualize. Okay, so this was just an example. Okay, and then we say that you can use the while also to set the limit. I'm sure you've gone through this, so there is no need. Okay, and just so kind of revision. So here too we said that the plots can have other parameters aside the x-axis and then the y-axis. You can choose the color of the of your line. You can also choose the line style, the marker, which is these boxes over here, the marker, the point at which the x-axis meet the y-axis, and then the sizes of those points. Okay, all right, so I think I have to open something. Okay, so we have the colors chart over here, so that we can also see the colors that Matplotlib use. Okay, so we move on. So here we just played with some of the colors and then with a threshold. Okay. All right, so this is the place where we got to. Okay, so we continue from here. So last week we ended at this session, and then we had a challenge over here. I'm sure you tried your hands on, and you shared your data visualization on LinkedIn. Yeah, so you need to also sell your skills out. Okay, yeah, you don't have to stay at your own corner. All right. So the bar chart is used to, I mean, group to plot a bar chart. I mean, a graph or a chart of let's say a summarized data. Okay, when you talk of a summarized data, so provided, let's say we are looking at maybe a department, okay, and we want to know the average score for science, and then average score for arts, business, engineering, and then the law. Okay, so average score. So let's say we want to know the average score of the students for maybe the science department, art department, business department, and then this. So you know that this is not individual, so it's a collection of the score for us to have a fair knowledge of which department and which student and which department has the students with most of the scores. So here in this case, we this is our dictionary and it contains science and that. So if you recall last week, I said that once you have this, you cannot use dictionary directly in plotting, but you can store your data as dictionaries. So once we've stored it, we need to extract the data within our dictionary. So the department average score dot keys will return the keys over here: science, arts, business, engineering, and then law. And then the department average score dot values will return the values over here. Okay, so once you have that, and then you use the list function to convert those values into a list. So once you have the labels, which is the department name, and then the scores, which is these, which you have extracted. Now you can now plot them. But ideally, in a spreadsheet, you can see that we have department over here, and then we have average score over here. So science, and then average score, art, and then average score. So similarly, these two that we've extracted can be considered as two columns of the data. Okay, two columns of a table. All right. So once we have these extracted and we've converted them to a list, now we can move ahead to plot. So to plot, the first thing that you need to do is to set the figure and then the axis variable by saying figure comma axis equals to plot because this subplot retains both the figure and then the axis. Then you specify the size as to the window in which you want to plot your graph. Now, once you are done, we have the ax.bar. So all that we are trying to say is that the axis, the plot that we are going to plot is a bar chart. So the x-axis is going to take the labels, and then the y-axis is going to take the scores. And color the bars blue, still blue. Okay. All right. So once we do that, that is what will happen. Then we can set the axis. So let the axis title equals to average exam score by department. Then we specify the font size and then the font weight. Then the axis X label, so the name of the X axis. So how are we going to label it? We want to label the department. Y axis, we are labeling it average score. And then the grid lines. So last time I made mention of the grid lines. When you use the double dots, you have dashed lines. When you use single, you have a straight line. All right. So in this case, we want dashed lines, and then we want the axis to be y. So in this case, we set the opacity, which is the alpha, to 0.5. And then we set the y limit to 60 to 90. Why? Because the scores falls within the range of 60 and 90 so that it will not start from 0. All right, so once we done, we run the plot.type layout to prevent overflow. Then we also run the plot.show. So once we run, all right, so you can see that we have our bar chart beautifully displayed over here, where we have our axis title over here, y label over here, and then x label down here. All right, so basically that is what this does. So using the colors, we can change the colors to our preference using the Matplotlib color chart. All right, so here we can choose from any of the colors here by name. So maybe we would like to maybe use teal, okay? So teal we want our plot to be teal. All that we need to do is to specify from here. So here we are going to say teal. All right, so you see that we have our bar chart in a teal color. Okay. Likewise, you can also change the opacity, which is the grid lines. You can change it into opacity, and then the Y limit. So imagine there is no Y limit like this. Let's see. So it's like it starts from 0 to the last value, and it does not help in differentiating between the borders. Though you can see it, but it's not too clear. When you bring this one, it makes it much more visible. And so now you can now quantify the distinction. Okay. All right, so basically that is how the plot goes. Okay, so we can also color the bars based on a condition. All right, so here we say target equals to 70, 75.0, which is the pass threshold. Okay, and then we say bar colors equals to mediums, medium, mediums, what? Sorry, medium sea green. Okay, so medium and then sea green. And then if score greater than target, else coral for score in scores. All right, so what that we are trying to say is that the scores that we had over here previously here, what that we are saying is that if the score is greater than the target, which is this, color it medium sea green. But if the score is not greater than 75, color it coral for score in those scores. Then once we are done, then we set the axis and then the figure. Then bars equals to args dot bar, labels, comma, scores, comma, color equals to color bars, which is this. So is in this case, the color is now a condition. So once you put the color equals to color bars, color is going to, the color that will be chosen will depend on this particular conditional statement that you've written. So then we set the title, we set the label, we set the Y label, then we set the ax dot line. So remember that the ax dot line is used to set a particular threshold, whereby you see a line drawn to show that this is the threshold. So in this case, we are saying that Y equals to the target, and then which is this one. Okay, that is the threshold. So which threshold do you want to use? The target over here, and then we want to color it black. The line style should be dashed lines. The line width, which is how thick the line should be 1.2. Label, so we are going to label it target. Okay, so target and then the value. Okay. All right, so we say ask dot legend. So here we are going to add legend to it to explain all these the x-axis, the y-axis, and then also this one. All right, then the grade, we set the limit to this tight layout. I mean, all these things are generic, so based on your needs. Okay, so now you see that it's the same plot that we plotted over here, but using the condition. Those that they have scored above 75 were colored green, and those that they have scored less than 75 were colored coral. And then you can see our threshold over here. So provided our threshold is cost to 80.0, and we run, see that now we find out that it's only engineering that qualifies, because it's only engineering that has a threshold greater than 80 based on this particular condition. So the rest are colored coral because they do not meet. And you know that we've seen that the threshold has also moved. So we can choose a different threshold from here. So golden rod, you can use a golden rod as the threshold color.
Daniel,
Yes, I'm listening, Grace. Yes, Grace, I'm listening.
please can you explain those colors over there?
The colors. And which part? Which, I mean, you don't, like, tell me the exact problem. I should explain as in,
I want to know how
Okay, so
you had
please go ahead.
colors at the other side, the named colors. Yeah,
Okay, these ones. Okay, so
yeah.
it's actually
Only
a chart
colors.
that I downloaded.
Uh-huh.
Yes, only colors. So it tells you the color palette, okay, list of the color names. So I downloaded it from the Matplotlib website. I shared it on the class page. So once you have this particular notebook and you downloaded it, I
Okay,
mean,
that's fine.
you downloaded it from the class page and load it. You have all these colors and then you can use it to modify your charts based on what color suits best or which color preference you would like to go for. Okay. All right.
Okay, okay,
So
that's
here
fine.
is a bit okay. So here is a bit complex one. So in this case, we want to add values on top of the bars. Okay. So provided this one, we want to add its value here, and that's its value here. This one, the value here. This one, the value here, and so on and so forth. So for that one, what that we have to do is to now we create our axis. We specify that we are going to do a bar chart. All right. So then the color is a steel blue. All right, then we say that for bars in bars. Okay, for bar in bars, I mean, we mean this one. Okay, for all the individual bars, height equals to bar dot get height. So this retrieve the height of the bar. Okay, then ask dot text. So here you are formatting the text. Okay, so now this height that you've retrieved, which is the height of the bar, this one, you are going to format it. Okay, so bar dot get x plus bar dot get weight over 2. So this center the bar in the middle. Okay, and then this one gives it a bit some space above it. Okay, so here you can't just write it right close to the bar chart, so you just move it a bit. So here we specify 0.3, and then here we just also label it, and then we put the height value, okay, to one decimal places. Sorry, one decimal place using this. So the 1F is kind of a formatting that converts this particular value by which is the height over here to a one decimal place. All right, so we say put it in the center, and then all right, and then just some formatting over there. All right, so now let's run it, and I think this also generic, and then all these ones we know it already. So the only thing is just this particular for loop which runs through all the bars and then get their height, and then all that this text is doing is to put it one decimal place and position it right above in the center. All right. Okay, so you can see that we have sines 78.4. So, however, without these values, you might not know the exact value. And then 72, this and that and that and that. Okay, and possibly this particular for loop
Daniel,
is what is doing.
Daniel,
Yes, Grace.
Daniel, please can you
Yes,
explain
Grace,
the
I can
part
hear you.
that you've highlighted, especially the bar dot get something? I don't understand.
Okay. All right, so here the bar dot get height actually here gets the retrieves the height of the bar. Okay, all right. So in this case, once you have the height, so now you are dealing with each of them as an axis because of the for loop, because the for loop will pick each of the bar. So in this case, the axis is just centered on that particular height or that bar. Okay, so what you are trying to do is that the text which you are writing over here, you want it to be in the center. Okay, so for it to be in the center, then you need to calculate. Okay, so this bar dot gets x plus bar dot gets width. So it's actually calculating the height and then the width in order, and when you divide it by 2, it allows Python to center your value over here, which is the height in the middle. Okay, so basically that is what I can say about that. So this particular thing, that's what it is doing over there. Okay, and then this height over here actually pushes it a bit above your bar, because when you comment it, let's try and then see. Let me just try and comment that part. Okay, and run it and let's see. Um, okay, I think I've done. Let me just delete everything. Okay, I mean so that you can see. Okay, so provided it's not there again. Okay, so over here, Python is saying that the text function over here actually requires this as a positional argument. So without this, this particular expression is required, because if not, Python will not know where to put your value. Okay, so that will be an ambiguous issue. So in this case, once you add a 3, it just places it, where is it? Come on. Okay, so once you run it, it just places it, I mean, above that. Okay, but ideally, I think even if it's not there, it should be working though. So yeah, but I think because of the positioner, because like when this function was being um, um, written, there was these all these functions are required. Okay, these parameters are supposed to be provided. Okay, all right. So basically, that's what it's doing. So this one centers it in the middle. This one places it just right above. Convert this one to a one decimal place. Okay, okay. Then I think there's these ones are just some expressions to just help the plotting. Okay. Grace, I hope you get it now.
It's okay.
All right. Okay. All right. So let's make progress. So that's that for the bar chart. Yeah. So that's that for the bar chart. Any question aside what Grace said? Okay. So if there is no question, then let's make progress. Okay, so we also have a horizontal bar chart. Okay, so when the category names are too long, and then writing them here will not be too convenient, because they will take a lot of space, and then over here. So we just use a horizontal bar chart, and it has the same or similar implementation. So using original sales as a dictionary, we extract the values over here and then the values over here using the original sales dot keys, and then that's what the values over. And then we specify, or we initialize our figure, and then the axis. Okay, so if you want to do horizontal bar charts, all that we need to do is the axis dot bar h instead of only the bar. We specify x-axis, y-axis, and then the color. Then we set all these parameters, which we know already. Okay, and then here you see that the values labels at the end of each bar. So now look at the another implementation that was used to add values at the end of the bar. So you see that for I comma value in enumerate totals. So we know that when you enumerate a list, it provides for you the index and then the value. Okay, so ax.text, so value plus 400, comma, I then, which is the index. Okay, so the index kind of represents this particular value over here. Okay, and then so here you have the value over here, and now we are not putting it to any decimal place, so we just want just the value like that. All right, so then we specify this parameter and set it to center, and then the font size. Then we just use a title layout, then the PLT does show. So let's see that's also in real action. Okay, so you see that basically this long for loop is something that has been compressed into a particular list expression, very short like that. And you can implement both of them in your coding. Okay, so one thing I would like to say is that you just follow the same procedure to see whether it will work for you. Okay, all right, and then you change the parameters to see what could go wrong once you are working on that, so that it also helps you to develop a better understanding of what the code is also doing. All right, but basically these particular parameters are the same parameters that were provided over here. Just that here it was open, and then we used a particular expression over here to just calculate for the center of the bar. All right, so once you have this, you're going to have their values attached to it like that. Okay, based on just the only difference is just this code and then the bar age, but the rest are things that we already know. Okay, please, any question up to this stage?
So please explain the AS dot test something, that part for me, please.
Ax.text. Okay, I'm coming. Okay, so the AS.text. Okay, so um let me just open this one up so that we get to see it clearly. Um, like that, like that, like that. Okay. So basically, this is the code that we have over here. Okay, I want you to just look at it carefully and then look at this code over here. Okay. So it's the same as actually this like this code. Okay. But those are this place we are implementing the get height and then the get x value and then the get the width of the particular chart in order to specify the center. But in this case, because it is a horizontal plot, we are not specifying all those parameters. So here you have I, which is your index. So the value, every value that you have for these values, you are going to add it up to 400. Okay. All right. So once you are done with that, then this will become your index. So um, basically, all that this one is trying to do is that the axis of each of these particular bar charts, as we specified earlier, it is this axis that you are performing these particular operations. And these operations is to just put the labels at the end of each of the let me see. Okay, at the end of each of your bar charts over here. Please, can you see it? So this axis refers to each axis of this because of the for loop. Okay, because of the for loop, it is taking each of the axes one by one. So until it works with this, it does not go to the next one. So in this case, the eastern region first become the only axis that the Python is working with. Okay, so it's plotted as it is. And then now once it's being plotted, it tries to recall or get its value over here, which is at 26,800. Okay, so with just this format, so you can see that this is just a way of formatting this 26,600 because that is not what we have over here. Okay, and then this tells you which index that it should use. So that's going to be index 0. Okay, and then you also have like this value also is to help you like I'm coming. You just give me a moment. Let me get that one. Basically, what's the the value plus 400 is kind of let me check. All right, so it's kind of performing this particular tax over here. That is the height plus 0.3. So it's more of positions the text about 400 units from the end of the chart. So, I mean, going into details as to each of what each of the parameters does, I mean, is good. But there is also another way of implementing it. That is knowing what should be there. I mean, provided what you want to do. So in this case, you can adopt this particular code when you want to position your values at the end of your table. Okay. And therefore, these are some of the parameters. And then this one, just as I said, positions the value 400 units. And then the index, select this index so that the value um, is being positioned, I mean, the text is being positioned on that particular line. So when you take Eastern region, it cannot use a different value, okay? And then the text has to be positioned on that particular corresponding um, um, Eastern region, I mean, corresponding regions over here, or else there is going to be a mix-up. Okay, so basically that is what this ask.text do. So it's a way of just formatting this text over here. No big deal. So you can just adopt and then you try your hands on it to also figure out other things, maybe something that you can learn from that. Okay, so we also have another one that we call the stack bar chart. So the stack bar chart actually has different bar charts stacked on one another. Okay, all right. So for instance, let's say we have three columns of a particular table as we have shown over here. All right, so in this case, you want to plot the stack plot. So let's say when you take January, and then maybe you're saying that, okay, of the January, how much of it was for Accra branch and how much of it was for Kumasi and how much of it was for the Tamale. So in this case, you want to do a plot bar chart for each of the months in order to compare it directly, other than plotting them like bar charts, maybe a number of bar charts, or maybe plotting them one after the other, or comparing it one is to one. You can just use the stack plot. So that thing for that one, so what we do is that you just specify the figure size, I mean the axis, and then we say that ax.bar. Okay, then branch, that's the x-axis and the y-axis. Then we have the label. So this become your first bar chart. And then the second bar chart, which will be on top of the first one, we have to specify the bottom. And here we are saying that the bottom is the values branch Accra. Okay, so the branch Accra values will be the initial values for this particular first value. So it means that build on the bottom values, which is the branch Accra. And then we have the ax dot bar. Instead of the month short, and then tamale, because that's the tamale that we want to use. And then we label and then color. And then we see that the bottom, we see that A plus K for A comma K in zip branch Accra. So we know that when you use the zip puts two lists together. And once you have the two lists together, it returns a tuple for them. So with that tuple, we can access each of the tuple. So here in this case, when I put this and that together, using the zip, I'll have this and that in a tuple, as in something like this. So 1 to 400, comma, and then 9, 800. Okay, like that. So I can say that let A kind of A comma B equals to this, whereby the A will inherit this and then the B will also inherit that one. Please, you get it? All right. So once you have that, we are saying that for A comma K in zip branch and everything. So what you are going to do is that we are going to add A and K. So for what I did over here, so for this one, let me use the K just to relate it much more easier. So A plus K is going to be this plus this value. So for January, I'm going to add this and that. And that will be the bottom for the third one, tamale. All right, so for February, I'll do that because we are running a for loop through all the values in Accra and Kumasi. All right, so to demonstrate that, I'll just like to just pick this one here and then maybe create something up there. Okay, so then let me just run this one. Okay. And let's say for A plus K. So let me just run. So A comma K in zip comma set. Okay. Print A. We run it in the for A comma K in. Okay. Print it. Okay. So you can see that for A comma K in zip print A, it prints all these values. So let me just format it a bit. Say F, then here I say this, and then I'm going to say here let me say something like that. Okay, then I'm going to say print here the K. Okay. Okay, so I just need to put this one in that. Okay, so you can see that you have the 200 over here. 100, so sorry, 12,400. 12,400 and then 108. Come on, 108, 142, 142, 135, 135. And then you can see that all these values are here. So it means that the zip actually produces a tuple. Okay, all right. Okay, so let me see. And equals to the zip. So, okay. All right, so once you have that, and then since you have two values, those two values will be returned, this and that. So in this case, we are adding them. So instead of typing them manually, we are just using a for loop to add these two values like that. And then on top of that, we will plot the tamale values. Okay, these things are all generic, which we've seen already. Okay, so you can see the proportions. So you see that the Accra, so we use the legend. When you use the as.legend, it returns the legend as in the specifications of the color by the color, as we know in Excel. Okay, so you have your for January, you know you have your this value. Okay, and then you have that and that. So you have January, and then you have for January for Accra, January for Kumasi, and then January for Tamale. So with this, you can say that, oh, in January, the sales from Accra was higher than that of um, Kumasi, which was also higher than that of Tamale. So that is how we do a star plot. The only invention over here, we are using the same bar plot with the same specified parameters. But here we have to specify the bottom, which should be the value upon which the new um, the new value or the new bar chart should build on. Okay, so once you do that, you have this. Please, any question? Okay, so if there is no question, then we are making progress. All right, so we have a small challenge over here, and then we also have histograms. All right, so histogram shows the distribution of a data. So is the data normally distributed or not? All right, so when you use a histogram, it tells you that. All right, so it divides the values into intervals. So intervals in Python, we use bends to know the intervals. So if you remember when we were in GHS and SHS, you have to plot a histogram, use an interval. So you plot one graph and then using the last line as a new value for the next one, you plot another bar and you plot another to know how the data is being distributed along around the mean. Okay, all right, so we use the bins as the intervals. Okay, all right, so let's see that in an example. So we said that use it when you want to understand the shape and spread of one numeric column. Okay, you want to see whether values are symmetric, skewed, or split into two groups. You are exploring a new numeric variable for the first time. So it's just like trying to find the shape, which is the distribution, whether it's normally distributed, or it is skewed, or the data is scattered, right, around the mean. Okay, so what we do is that we have some scores over here, exam scores. All right, so we have one list containing all these values. Okay, so in this case, we can just print the minimum. So this is just an overview of the data where you want to find the number of values when you use the length to find the number of values, which are the number of data in that particular column, the minimum value of that column, the maximum, and then you calculate for the mean, which is the sum over the length, and then you put it to two decimal places using the round function. All right, so with the histogram tool, we just have to specify our figure and then our axis. So once it's being specified, then we are going to use the axis dot. So in this case, because we are using histogram, the function shortcut or short form is called hist. So the hist, then we specify the values, which is the score over here, the scores over there. All right, so we are saying that the bins, the interval should be 10. And then the color that we are giving to it is still blue. And then we want the edge color to be white. Okay, all these things we know already. Okay, so all that you need to do is to just specify this, but you don't have to forget the bins, which is the interval. So divide the score range into 10 equal intervals. Okay, all right. So once you do that, so you can see that now we have our data plotted, and then the edge that we specify to be white, that is what is becoming white over here. But I think if you don't specify, I'm not sure that it's a position argument. It's not going to return anything. And so you have your histogram plotted together like that. Okay. but I think maybe it could be ideal to sometimes draw it to know the boundaries. Okay, to know the boundaries. It helps. All right. So once you have this, you can tell that okay, this data looks like normally distributed, or maybe it looks skewed to the right. Okay. So based on what you want, I mean, and based on observation. So for me, I would say that the data is a bit normally distributed because it has that kind of a bell shape. Okay. All right, so that is how we do it. So let's change the bin size to 20 to see how it will be. Okay. All right, so 20 distributes divides the score into a range of 20. Okay. All right, into ranges of 20. Let's make it 5 and then let's see. All right, so when we make it 5, it divides the score into ranges of 5. Okay, so 1, 2, 3, 4, 5. Okay. All right, so for the score, the highest value to the minimum value, so from 45 to 100. So it splits it into 5 and then it provides that particular boundary. Okay, so Python will calculate the boundary for you. And so it's a plot by dividing your data into 5 intervals. So I think 15 will be good. So you can just rotate it, maybe because the 5 will not help you to know whether it is normally distributed or not. So when you take more bins, it helps you to also know it's that we can have some data which looks like an outlier. Okay, doesn't look like it's part of this data over here. But overall, the data looks more like normally distributed. Okay, but these two looks like an outlier. But when we use 10, we did not see those outliers. Okay. All right, so when you use 10, it looks like those data are very close, but in reality, they are a bit far away from the other ones. So using the histogram helps you to know about the distribution of your data, and it can also spot outliers, like um, um, yeah. So like what's the name of that plot? I've forgotten. Yeah, I've forgotten. But it also used to help to define the um, distribution, which when, and you know, it's only for that one, it gives you the percentile, then the 75th percentile, and the 50th percentile, and then the 25th percentile. Okay, and then the 50th percentile, which is also equal to your median. All right. So when you have this particular histogram, you can plot the means and then the median lines. And then this one, we are going to just use our threshold method, which we implemented when we did the line plot and also the bar chart. So here, all that we are going to say is that the mean, we are calculating the mean. So the mean equals to sum over the length, and then the shortest scores equals to short scores. So in this case, we are arranging the scores from ascending or in ascending order. That is from the lowest to the highest. And then we see that n equals to the length of the scores. And then we are writing a condition over here. We see that if the length n, the length of the shortest score divided by 2 equals to 0, median score equals to scores, that is the shortest score, so that it's a list. So all that we are trying to get is the n value, so that particular n over 2 minus 1 plus shortest scores n over divided 2. So this divided 2 will actually return to you the whole number, and then you divide it by 2. And when you look at this one closely, it looks like the formula that you use to calculate for the median if the value is an even number. So what this particular expression says is that if n divided by 2 gives you an even number, because this modulo operator will return the remainder. So it means that if n divided by 2 and it is 0, then it means that that value is an even number. Then you have to calculate for the median, or else if it is an odd number, then you have to just get your median value by dividing that particular number by 2. So that is how we calculate our median. So median equals is the middle number. However, if it is an even number, you are going to get two numbers, whereby what we do is that we add those two numbers, this plus that over that. So what we do is that n divided by 2 minus 1. Okay, so that is n divided by 2, that is so provided n here is, let's say, 5. So 5, this divided 2 is going to give you 2, because 2 will go into 5 two times. Remember 1. So 2 minus 1, okay, plus then the same sorted value. So n divided by 2 to get a particular value. Then you add them. Once you are done, then you divide it by 2. So it's a median formula that we've implemented. Very simple. But here in this case, we are using the n, which is the number of values within our list. Okay, and then we are saying that this, so n divided this minus 1. So that will be the index for the score. So it's going to return that. So I think I should do that one outside this thing so that you guys can see what I'm trying to talk about. Okay. So we have the scores here. So let me just read. It's all about it. Okay, so we have that. And then we also have the scores over here. Okay. So these are our scores, okay, and then this is the median. So I just also need this one. Okay. All right, so sorted score will arrange the scores from little to the highest, because if you want to calculate for the median, the values has to be arranged. Okay, so once we have that, we get the length, which is the length of it. So let me just do the print length. Okay. Print n, which is the length, and then print sorted scores. Okay, so let's do that. So you see that this one has been arranged in ascending order, and then the length is actually 60. So there are 60 values within the list. Okay, and then we are saying that sorted n. So n, let's say here is 60. So 60 divided by 2. So let me just run that. So 60 to, let me just bring that. Okay, so 60 divided by 2. So 2 going to 60 how many times? 30 times. And it returns the whole number, not the division, the divided number. So 60 minus 1. So that's going to be 30 minus 1. That's going to give you the 29 value. And then here, n divided by this. So this is going to give you 30. So scores, that will give you the 30th value. So because the middle values, when you divide 60, is 30. So we are using 29 and 30. Okay. So 29 plus 30 over 2. That is basically how we calculate median when the value is an even number. So that is what we were doing over here. So we say if this particular expression. So if even number, okay, that is n divided by n percentage or modulo 2 equals 0. That is if even number. Calculate the mean. Or else if it is not, just divide it. The mean will be the middle number, because when it is odd, you divide, you are going to get a single value. It will not fall within two particular values. Okay. All right. Okay. So once you are done, then you are just, so here is just a way of printing and then setting the decimal place to 2. Then we specify our figure and axis. we use the same haste. And then here we are changing the opacity to 0.8. So the opacity takes is the alpha, the edge color is the same white color blue. The number of divisions or boundaries or intervals is 10. So it's going to give us 10 different blocks. All right, so we want to plot the mean score and then the median. So you know that previously we were using axh, but here we are using the axv, which is the vertical line, because at first we were using axh, which draws a horizontal line. So axv score. So what do we want to plot? We want to plot this mean score, okay, and then we specify the color, the line width, and then the label. Okay, and then the same thing for the median. So these things are generic. So once you run this code, you see that we have this distribution, and then we can see your mean and then your median. So the mean and the median are a bit close. Okay, right. So just that's how you do it. Very simple. Okay, so I think this one was an example. So all right, so we can use a tuple to return a threshold, and it uses the same thing. So the axv, what that we are trying to do is that we are getting the threshold instead from maybe using this particular calculations for the mean. We are just setting some values to a tuple to score boundaries. So 0 minimum, 50 pass, 70 merit, 85 distinction, 100 marks. Okay. Then we see the pass mark equals to score 1. So score 1 is 0, 1. So meaning that this 50. So pass mark equals to 50. So in this case, we are just plotting and saying that ask dot haste exam score, that the same thing. Opacity, I mean the how deep it is. We set it to 0.8. So it ranges from 0 to 1. So 0.8 means that it's a bit deeper. And then we set the line, the threshold line. Okay, so we say the pass mark, okay, which is this one. And then the mean score, which is the previous one, and the mean score that we calculated from here, because we are using the same student data. So once you run that, so you can see that the pass mark is here and then the mean score is here. So all that you can say is that considering the pass mark, most of the students had a mark greater than the pass mark. So looking at this data, it speaks a lot. Okay, so I can tell you that, oh, the student actually did well, because almost most of the percentage of the students had a mark that is greater than the pass mark, which is this particular threshold. Because when you look at this threshold, it's just only two boxes which are here. Okay, and then the number of students are kind of ranges from 0 to 2, so almost 1. Okay, but majority of the students, okay, had values that are greater than the 50 threshold. And then the mean mark, so the average of the mark, so the mark is mostly centered around 76.3, which is shown over here. So you can see that using this particular chart, you are developing a lot of intuition, and the code to implement it is easy. So I would like you to just go through. Once you put your hands to the practice, you even develop more understanding. Okay, and then you can change things. So here, you can change the bin to 15. Once we change it to 15, okay, so you see that we have an outlier over here. So even within this particular range, there wasn't any student score. But however, with this, it gives us a fair knowledge of outliers. We can set it to, let's try with 100 to see how the plot will behave. Okay, so with 100, see how it's behaving. Okay, so the number of intervals, so, and this does not give you, though it gives you a fair knowledge, but it does not give you a very good sight of the plot. But you can set the bin to these high values in order to get outliers, values that will not are not too close to the to all other values or to the mean, because the value shouldn't be too far away from the mean. If it is too far away from the mean, it can be considered as an outlier. Okay. So that is that. So overlapping histograms. So imagine you want to compare two columns. All right. So let's run it and see how it works also. Okay. All right. So here we have two different distributions of this. Okay, but I mean maybe it may meet your experimental needs. So here in this case they used control and then the treatment. So we want to know the distribution of the control and then that of the treatment, how they responded to a particular medicine or drug. So let's see the code. So we have glucose control, then we have the glucose treatment. They all have their glucose readings. Okay, so we start and then we say that ask.hist, and then we specify the value and then the number of bins, then the color, the edge color, the opacity, and then the label, which is the control group. Okay, all right. So it's the label that the legend will actually pick and tell you that this is a control group. All right, so we set another one to with the same thing, the same code, just that we just change the value. Okay, then we set a threshold. Okay, so 70 days and that and that. And then we say that ax So here we want a vertical line. Okay, and then we say glucose underscore threshold 2. So this particular two, so there's going to be 0, 1, and then 2. That is, we are taking the 126, okay, which is the threshold. So, I mean, when you get any value beyond that, it means that you have diabetes. Okay, so we set the color to red, then the line star should be dotted, line width, and then the label, we are going to call it diabetic threshold. And the label is important because the legend will learn from that. Okay. All right. So once you're done, you set your title, your Y label, and then legend, and then you have that. So in this case, you've plotted two histogram, okay, together. Okay. Right. So here is actually the mean, okay, the threshold, the 126. So you can see that here you can see that the control group, okay, had glucose level greater than the um, um, greater than the treatment group. So those that they were the control, I mean, so those that they, let's say, had the diabetes, so these were their values. And when those people were treated with with a drug, these are their distribution. And then you could see that now the data has shifted from this particular range to here. And then when you look at the distribution, you can't say it's a bit normally distributed though, but this part doesn't look like a normal distribution, and I think it's because of how the data values has been structured. But it also gives you a fair knowledge or idea about a comparison between um, a category of people who took an intervention and a category of people who did not take an intervention. Okay, so with that said, we move on to scatter plot. So scatter plot is to help to explore relationship between two numeric values. All right, and then it used dots. So let's see, we have this particular student's records as a dictionary. Okay, so we are extracting the study hours over here, and then we are also extracting the exam score. So in this case, we want to find a relationship between the study hours and then the exam score. So once we have that, we just run it. And then once we run it, we have those values extracted. Study hours column and then exam score column. Okay. Then to plot the scatter, you set your axis first. You define your size, and then you say ax.scatter. Okay, so because we are using scatter plot, we use the scatter function. So you provide x-axis, y-axis, color, opacity, which is the alpha, and then also the size of each of the dots, which is 80, or which is the marker size. All right, so let's see when we run it. Okay, so yeah, you can see that there is a positive correlation between the exams, the weekly study hours and the exam score. So as the weekly study hours increases, you can see that the exam score also increases like that. Okay, and the size of this was specified by this S over here. So when you say 100, it's going to be a bit bigger. So as you can see, 100 increases it, and then and so on and so forth. So you can just play with the values, and then when you use 1, it will become very deep. So very deep. Okay. Or when you use 0.5, it will become very light. All right. So that is that. Okay, so coloring dot by categorical column. So we are going to color the dots based on the column. Okay. All right, so let's see that in action. So here we have age, glucose, diagnosis that is based on hospital data that someone collected. So ages equals to row age. So for row index, so we are extracting all the ages value, we are extracting all the glucose value, and we are extracting all the diagnosis value. All right, so we say that color map equals to healthy. So here we are saying that the healthy equals to medium green, pre-diabetic orange, diabetic coral. Dot colors equals to color map D for D in diagnosis. Okay, so we are saying that for the dot colors of these dots over here is equal to the color map over here D, okay, for D in diagnosis. So we say that for D in diagnosis, so for each of the values in the diagnosis, which is the diabetic, pre-diabetic, okay, the color map is equals to the color map of the D. So if it is healthy, it will be mediums green. If it is pre-diabetic, it's going to be orange. If it is diabetic, it's going to be coral. And then we are setting threshold. So fixed dot. So there's the threshold. So fixed dots, fig, then the axe, and then the piplot to set the size, and then the axis. So axis dot scatter, okay. And then here C equals to, which is the color. So we are setting the color to the dot colors, which is particularly this code. So in this case, what it is doing is that for each of the values of the diagnosis, you are going to use this color map. So if it is healthy, use medium green. If it is pre-diabetic, use orange. If it is diabetic, use coral. Okay. Alpha, the size should be 100, and then the edges color should be white, and then the line width, as in how bold the line is, should be 0.8. Okay, so we want to also plot the threshold, which is the 126. So we use the ax line h. So here we want a horizontal line. So we use ax h. All right. So we have a bit complex code over here. Okay. So you see the legend element equals to patch. So this patch is actually helps you in terms of your plotting. So once I plot it, you get to know, then I'll be able to talk about it a bit. Okay, so you can see that here the data has been colored based on their values. So pre-diabetic, that healthy to this diabetic, you have these things. And you can see that all the diabetic are above the threshold, but the pre-diabetic and then the healthy are not above. Okay. All right. So in this case, we actually use this particular plot this particular code over here to create our own legends. So you know that initially when you want to use the legend, we just run ask.legend, then we put it in parentheses. But due to the implementation that we want to use here, we use the patches over here. And I'm not going to explain this code. So once you have it, you can just try. Or if you want to use it in your code, you can just adopt the method and then you'll be good to go. So just know that once you have this particular code, it helps you to get the legend, which is this for such a plot.
Daniel,
All right, but I
Daniel,
can, yeah,
Daniel. Please take
great.
your time. I'm
Yes.
getting confused. Can you explain the things you are explaining again? I don't know.
For this particular place
Yes, I'm
or the
confused.
previous one.
No,
Okay,
this
so
the one
this
you are
part,
doing.
okay, so the one that I'm doing. Okay, so imagine this code is off. So let me just take it off by just commenting on it and let's plot it and see. Okay, so you can see that what we are doing is that you see that we have values over here. Okay, these are the values, and then you see that ages equals to extract all these ages, glucose, extract all the glucose, diagnosis, extract all the diagnosis. And then we are saying that color map here, we are creating a dictionary. Okay. And the dictionary, this key, when you have a key healthy, the value is mediums green. When you have a key pre-diabetic, the value is orange. When you have the key diabetic, the value is coral. Okay. Now, once we are done creating that list, that dictionary, we create a list. And in the list, all that we are saying is that this color map over here, D for D in diagnosis. Now we know that the diagnosis value are these healthy, diabetic, and all those stuff. So we are saying that for the each of the values in that particular um, column, okay, in that particular column. All that we are trying to say is that for each of those values, so for each of the diabetic, healthy, and pre-diabetic, color map those values. So in this case, all that we are going to retrieve is that when you pick each value, so let's say diabetic, here we are going to say color map diabetic. So here, when you come to the color map, which of the which of these is diabetic? Which of the keys is diabetic? It is this one. And what is the value? It is coral. And so when you come down here, we are saying that for 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 the colors that you want to color each of the dots, use this particular color. So we are saying that if the color is if this diagnosis is diabetic, color it coral. If the diagnosis is pre-diabetic, color it orange. If the diagnosis is healthy, color it mediums green. So that is what this particular code is doing. So instead of saying that color equals to one color, we are saying that color equals to check. Use this color map to check for the diagnosis. If the diagnosis is healthy, mediums green. If the diagnosis is pre-diabetic, orange. If the diagnosis is diabetic, use coral. Please, do you get it now? Grace, do you get it now? Grace. Okay. So once you are done and you plot, this is what you're going to have. So we know that this is diabetic and this is, but this one, if no one tells you, you wouldn't know. So that's why we implemented this particular code to create legend, and then we use the matplotlib.patches. Okay, and I'm saying that all that this one does is it just gives you the ability to, provide legends here to explain what each of the points mean. Okay, but I'm not going to go into details with that because there are more options that you can use to, plot your legends, but which we will see in our later courses. But this one was just implemented to just show. Okay, but however, you are not you can also adopt it in your code to rehearse it, to visualize something. So let me try to explain a very something simple over here. So we say that the legend element, so we are specifying the legend element and we want to output it into a list. And then we are running this patch function. And then we say that the face color equals to color map cut. So the color map cut over here, all that we are trying to see do is that we are going to specify what these colors, okay, mean. Okay, so that you know that, oh, when you have the medium green, it is healthy. When you have the orange, it is the pre-diabetic, and when you have the coral, it is diabetic. So that is what it does. And then we say that use the label cut. Okay, all right, and then you say that for cut in color map. So for cut in color map, as in for each of these values here. Okay, so you are going to just map these ones to this. All right, so that is basically what this code is doing. And then you set the label to the cat, which is the category over here. And this particular category refers to this healthy and then diabetic and this. So you are mapping that one to their colors, because when you have a dictionary and you run healthy into it, you're going to get mediums green. So this patch is actually drawing an association between this and that to be used as a legend. Okay, and then you see that legend.element.append. So what that you want to append is plt.line 2D. So this is what plots your legend. So this one maps your legend. Let me just add it as a comment. Okay, maps your legend. And then this one plots it. All right, so to plot it, we use the line 2D, and then we specify the axis, which is zero axis, and then zero axis, and then the color, and then the line style, and then the label. Okay, so let's see that. So once we do that, you see that now the diabetic, where is it? The label diabetic has come, all right, with the line, and then the patches also has come, as in the colors. So healthy will be associated to that, pre-diabetic will be associated, and so on and so forth. So you can adopt it in your code and rehearse on that. I mean, when you have the notebook, I think you have it now. So once you take your time to go through, you will truly understand. Okay, so Python has pie chart, and I think that will be what we will talk about last before we leave. All right, so we know pie chart. So pie chart is used when we want to count how many records fall into each particular category. All right, so here we have this particular diabetes data set. So we have labels equals to list diagnosis dot count to get this, and then sorry, these ones, and then the values to get the values. So we just print them. So once you print them, you have the data like this. So next thing, what that we need to do is to specify the figure and then axis. Then we use the ax.py. Okay, then we say sizes, then comma, labels equals to labels, which is your labels over here. Okay, so here we need to specify the sizes as in the proportions, and then the labels be equals to labels, and then the auto PCT, which shows the percentage on each side, on each slice to 1% decimal. You also specify, so 1% and then decimal. So let's see that in action. Okay, so you can see that now we have a pie chart drawn here showing the proportion of each of these particular values to the whole. So pre-diabetic was 28.2%. So maybe you can say that, okay, at the end of the experiment, we realized that the patients, about 28.2% were pre-diabetic. 33.9% way. So maybe this can be a demographical experiment whereby you learn about the diabetes status of a particular group of people. So after that, you can use the pie plot, sorry, the pie chart to tell what proportion of people are there. So what percentage of the population is hypertensive? What population of the people are healthy? What proportion? So this can tell us that, okay, because most of them, most of about 33%, which is the highest, but we can see that 15% is this. So what can we do to reduce the 50% to 10? So it also helps in informing decision, and this is just the code. Okay, so this one, it shows the percentage, but this one just turns it to the one decimal place, and this is the implementation. So I'm not going to explain to you why there is this implementation, but all that I'm trying to tell you is that it shows the percentage in one decimal place. Okay, so just know what it does, and when you want to use it, you use it in your code. Okay, so once we are done, we can also customize it. And let's see that one in action. All right, so yeah, you see that we've splitted it, okay? But I mean, this one is just for fancy sake. But however, when you have this, it's also good. But let me try and then explain it a bit. So now we have the colors over here as a list, and then we have explode, okay? So how we want to pull, okay? So, or how we want to split this thing, then we specify it over here, okay? All right, so we specify the figure and then ask, and then it has a lot of parameters over here. That is the wedges text and then auto text. And then we see that sizes, labels, cost labels, auto-PCT. So we know we have all these things already. We have color equals to colors over here. Okay. And then we have explode equals to explode over here, which I've told you that actually split these things. All right. And then we have shadow equals to true. So it provides service shadow below your plot. Okay. And then you see that start angle equals 90. All right. So rotate the chart to the first slice at the top. Okay. So you see that for auto text does set font weight to bold. So that is just this text that we are setting it to bold. However, this is a bit complex. Okay. But you can also put your hands to it, try and then give it a try, and then try to go beyond what you are just seeing by just rehearsing. Okay, so once you are done, you are going to, and you plot it. I mean, you set the title, you bring the title layout and then the show. So Matplotlib is going to do this, and then it's going to apply all these parameters. So we know that this one shows the percentage in one decimal place. This refers to the labels over here, which we defined already. Okay, and then the sizes shows the sizes. The colors shows this colors over here. Okay, and then the explode takes these values. Okay, so you see that 0, this, and that. So you can see that the thing has been partitioned based on this particular values over here. All right, so you can see that we have 0 0.5, 0 0.5, 0 0.5, and then we have the 0 0.8 over here. Okay. All right, so let's see. So once you have a list of dictionaries, we can also extract the values and use it to plot. Okay, so count equals to for row in patient data, category equals to row categories. So that if category in count, category equals to +1. So what that we are doing is that we are incrementing these particular values over here. So we are counting them. So how many healthy is there? How many diabetic is there? And we are implementing this code. Okay. So here, if it is in a row, you add it up. If it is not, 1. Okay. All right. So once you are done, we will have a dictionary which contains each of these unique values and the number of times they appear in the diagnosis. Okay. So once you are done, the labels will be those values. So let me, okay, I think it was printed over here. Okay, so we have the dictionary. So healthy was 3 times, diabetic was 5 times, pre-diabetic was 3 times, and hypertensive was only a time, or it appears once. So once you're done, you extract them and you convert them to a list using the counts.keys and then count.values. Okay, so once you're done, then the next thing that you do is to just specify your figure and then the axis, and then you provide the parameters. Okay, so based on the number of parameters, 1, 2, 3, 4. So you give 1, 2, 3, 4 in that particular order. Then you plot them. So here, healthy would take the medium green, which we've seen over here, and then the diabetic will take the coral, which we see over here, and then also pre-diabetic we take the steel blue, and so on and so forth. So this is how you can see. So what I was saying is that you see that here we have diagnosis and then we have healthy diabetic. But you see that with the data that we collected, what percentage of them are diabetic, what percentage of them are not diabetic. This is the problem that you want to solve. And ideally, this could be a column. Okay, this will be a column, a whole column where you have the diagnosis of each of these patients. So what can you do? All that you have to do is to just use this particular accumulator to increment these values provided they appear more than one. So if they appear twice, add it to it and update its value to 2. If it is 1, just maintain it. So that's what this code is doing. So we set an empty dictionary to count, call count. We set count, which is a variable, to an empty dictionary. And we are saying that for row in patient data set, okay, for each of the rows over here, okay, each of the dictionary, okay, category equals to row diagnosis. Category equals to row. So the category of the diagnosis equals to row diagnosis. So extract all these. We are saying that if the category, which is this particular value, okay, is in count, is in this one, then the count category plus 1. So it plus equals to 1. So it means that if this particular healthy is in this one, okay, if it is in this one, then you are going to add its existing value to 1. Else you start with 1. So here when the loop starts, it loops through. So healthy is not in this place. So this one will be false. So here will be true. So here you have healthy 1. Then it will come to here diabetic. Diabetic, there's no diabetic here. So diabetic 2 will be set to 1. The third one is diabetic. Is there a diabetic? If diabetic in count, so we have diabetic already. So it means that category, which is the diabetic plus 1. So the diabetic value will be set to 2 because there is one value over here already. So another one, 2. So that is what the loop will do through till the last one. So once you have that, you will have a dictionary of these chain there. You set the axis, the index of the axis. Okay, so we can plot more than only 2. We can plot like 4 on it, and then the implementation is the same. Conclude that people at age 40 or above stand a higher chance of having blood pressure compared to people with less than age 40, because when you look at the threshold, which is the 140, consider the people of age 30, so starting from, let's say, 0 to let's say 40, let's say 43, yeah, they all have blood pressure less than the threshold. So you can see that it's very insightful. Provided you know what you are doing, you can do everything and you can explain it to anyone in your own way. So basically that is that. Okay, so once you have this chart, how do you save it? You have 2 ways of doing it, okay? So you can copy it to a clipboard. So once you copy it, you've copied an image. Okay, so you can paste it anywhere. Or else you also have a way to save it. All right, so if you want to say use the plot.save fig. So let's see that one in action. So we say that months equals to January and that we are plotting a subplot. All right, so sorry, we are plotting a line plot. So to have a line plot, once we are done, these parameters, we know them. We know all of these up to here. Okay, we know this title layout. So before we use the plot.show, then we bring the save fig. So the save fig, all that implies is that um Matplotlib should save the figure. Okay, so the save figure. Then we want to give it a name, monthlyrevenue.png. Okay, and then you set the DPI. So the DPI, okay, say that the dots per inch, that is 100 screen quality and 300 is for print quality. So the DPI sets the quality of the output. Okay, all right. And then you set the B box inches. Okay, so the B box inches also prevent the title or labels from being cut off at the edges. So for the ones that we had over here, you see that they have titles. Okay, if you don't set the B box over here, if you don't set this B box, if you don't set the B box to tight, it stands a chance of being cut off. So you see that your figure will be saved, but you will not have that particular how do we call it? That particular title on it. Okay, so once you do it, it will be saved in your directory where you've opened your Matplotlib, or sorry, your Jupyter notebook. So let me run it and then let me go to home and then let's check it. Okay, so once I open it, you see that that monthly revenue.png has been opened. And once I open it, you see that it's an image. There is no showing here. Okay, I think I need to open it in um something that can, let me see. Okay, let me just download it. A chance. So open. Okay, so I've downloaded it and I've opened. So I'm going to share that screen. Okay. So let me share that screen. I think that's our live slide. So I'm just sharing it and then you will see how it works. So you can save all your plots. Okay. Okay, so please can you see it? So there's the monthly revenue that we've, and it's very wonderful. So you can do this anytime, anywhere. Okay, so you have this and then maybe you want to present it or you want to add it to your anything. I mean, All that you have to do is to get something that you want, the someone that you want to show your work to, and that's all. All right. So, that's that. So that's how you can share. You can save your your files. So all the products we've made, you can just save them with this particular line of code. All that you need to do is to just use the same code and change the name. So based on what you are doing, maybe diabetes or something, then you put the name there. Then you specify the PNG. So the PNG shows the format, so, but you can use the JPEG, or you can save it to a PDF, or you can save it as a vector image, okay, SVG. So here you can even save it to a PDF. I mean, so let's try the PDF one and let's see. I think we are done. So let's try last one. Okay, so that's PDF. Okay, so let me go back to that. Okay, so it's even showing here. Let me go back. Let me just refresh that. So I think it's loading, so let's be patient a bit. Oh, sorry. Let's just pass the PDF from here. Okay. Okay. So I think, yeah, let's go there and then I need to, okay, so you see that now we have the PDF over there. Okay, so monthly revenue.pdf, because from this code I changed the value to PDF. So you can save even your chart as PDF and whatever format that you want from this list of format. JPEG is good for sharing. Okay, and then the PNG also is good for sharing. The PDF good for sharing. So once you have that, you can open the PDF and it's going to open for you beautifully. Okay, so basically we are done with the basics of Matplotlib. Is any questions so far? Please, any question? Okay. Yeah, so just go. You see that all that we do, they are repetitive. Okay. Only that the only thing that you need to be concerned about is to know what plot you want to plot and what you have to use. If you want a line plot, use ax.plot. If you want a bar plot, ax.bar. If you want to use a histogram, ax.hist. If you want to use a scatter plot, ax.hist scatter. Then you just provide some parameters, which once you go through the slide, you know that they are super easy. So the ones that we do, and then maybe we are trying to use a very some sophisticated or a bit complex. I mean, they don't matter so much. And for them to, they are static. What I mean by that is that you can just implement it in your code for it to do what you want it to do. So the goal is that not to understand what the code is actually, I mean, the very details of it. Maybe it's good to know, but I think it will worry you a lot. So all that you need to do is to get to know that, oh, this thing, when I use it, it does this. Once you do that, it will make your learning very fast. So um, um, once I use a code like, let's say, um, figure PLT figure dot save this particular code. Okay, you don't have to know what the DPI and all that you need to know is that once you implement this, it can output an image or a PDF. So if you want, each time you want to output, you just get to know maybe this parameter, what does it do? And then here we said that it's dots per inch is 100 if it is for screen quality. But if you want to print, you set it to 300. So provided what you want to do, you want to print it. So maybe you have to set this one to 300 so that it will have a print quality. Okay. Yeah. So the most important things that you need to know or most important parameters will be talked about. But if not for that, I mean, the rest you have to just get to know that this can be done in Matplotlib. And I know that there is something in it that can be used for that. What is it? So when you forget and you have a problem, you know that this tool can be used to do this. Let me go and look for it. Okay. All right. So please, we are done basically. So for today. So if there is no question, I think we can call it a day. And I apologize for the lateness because I had I because I got caught up in something. All right. So forgive me. So I will see you, God willing, on Sunday, where we will talk about NumPy, okay, Python NumPy a bit, and then afterwards we talk about pandas, and then we'll use pandas to do one or two. Then we come back to the visualization, and then we'll use some analytical tools, which will use Python package to get the T test and all those tests. All right. And for that one to, yeah, I think when it comes, you'll get to know. So hopefully on Sunday, I'm hoping to do the NumPy and then introduce the pandas. Then subsequent one, we do the pandas and then the visualizations together. All right. So please, any question for me? If not, we call it a day.